Welcome back guys. As part of my series how to build production safe agents, this is video 3. In video 1 we learn why 90% of production agents fail. If you have not seen it, go back and see, come back here. But that's not mandatory. And in video 2 we saw LLM are probability based. They try to be so nice to you that if you ask them your production database is slow, or or if it's blocked by some table, they try to be your friend who will try to drop the table because they think dropping the table will remove the blocking. A real concern because they are your friend but they are probability based, so you cannot trust them. So what kind of friends they are? They are friends who try to help you but they don't take in consideration you are working on productions and real data. So as part of video 3, so we will see that now we have defined the structural safety. Let's start building it. Every system starts with one thing: how it receives and understands inputs. We all know that. I understand how input enter the system. This is real architecture, not theory. I can replicate this pattern. Core idea of video 3 is before safety you need clean structure input. Yes, the core idea of this video 3 is you need cleaner input before you fed into LLM. So why this matters? Why clean data matters? Why LLM cannot do it? And the reason behind is simple. If you feed your body junk food, it will not be healthy. If you feed your body healthy food, it will be healthy. LLM are same. If you feed them healthy data, nice data, they will give you nice output, right? And that's the reason most failure don't start in reasoning. LLM are good in reasoning. They start at ingestion. If your input is messy, your agent will behave unpredictable. And we saw in video 2 how they drop table if your instructions are not clear. If you say to LLM, I have blocking on database, they will try to drop table because they think that blocking is because of this important payroll table. So this is not good for us, right? That means I cannot create production safe agent if data is not clean. That's why alerts are noisy. Most production alerts, people don't have any standards. Context is fragmented. Context from Datadog, Slack, different type of logs, your customization logging, and there are duplicate signals. Again, every 5 minutes you have alerts coming from different type of sources, and if you don't took action on alert, you will have every 15 minutes duplicate alerts. You need to define, is it really duplicate alert and to take further action. LLMs cannot reason those things, and that's we need to tell them. So this is clear, right? Garbage in, garbage out, remember. Third, we have different production input source, which we already covered. It can be email, webhooks, Datadog, Oracle Alert. So they don't come clean. Data is not clean. We already know in production. So the problem with what's the problem with raw input? Why LLM are so smart? Why can't they figure it out? You will ask. The reason is same. Agent cannot reason properly unless we normalize and structure this input first. But you will ask why? I know that, right? The reason is the context window. If you go to any model, they have context window. Some older model has 200K of context window. Newer one has 1M. This Opus 4.6, it has 1 million context window. Sonnet has 200K context window. And if you keep on giving it more raw structured data, they can't reason it. Their context window fulfill. And this is context window concept, this agenting concept we will cover in different video series. But the core concept is if you feed LLM raw input, it can interpret it the wrong way. Its reasoning power is not well and context window overflow. Now this is interesting. So I need to take care of my inputs. So what will be my pipeline? This is the most important topic, most important thing. If you have raw input, logs, email, we should parse it like any good data engineer parse their raw data. Parse it, extract it, normalize it. JSON format. Why JSON? Because JSON is kind of database schema which is fixed and you can validate it. If you put it in text file, MD file, Excel file, any other file, it's not schema based. If you work on data engineer, you know how good JSON is. You can put in Parquet format, any other format of database, but remember, JSON is the standard which understand by everyone. So normalize it. It goes to then this intelligent layer which remove any duplicacy, have your policy context. I mean, if your data is sensitive or not, if SSN or not, then it goes to specialized agent. It can be storage, SQL, RCA. So our job is to get this data first, this three pair as a data engineer, make it good parsable normalization data as a good intelligent network router, route it to right agent. We will know how to make it, don't worry. Then specialized agent, how to get, we will know. So what we get in the end, deterministic routing, no LLM decide which agent handle what roles to do. Intelligent router will know about it. IDM potent processing, what that means, no duplicate work, no duplicate work. That's what it means, no duplicacy, full auditability. We should be able to see from trace ID given end to end what's happening for our audit purpose and to make our agent continuous improvement. So remember this concept in agent: deterministic routing, idempotent processing, and full auditability. Auditability is what makes your agent debug better. Now comes the adapter layers. These adapters, you can have any kind of adapters which converts the serial word inputs to a consistent internal format. We know we convert it to JSON payloads, most of our input using log parser. So web conductor handle JSON payloads, data docs, standard HTTP inputs, whatever your source specific parsers are, one normalization output. LLM should always give one normalized output format, and that should be JSON. Future it can change, but currently JSON is the standard. All good? Post comment if you miss something. And this is what we want them. All the sources. What the source? First the incident ID. What's the entropy hash, from where it came, so that we don't have duplicates. Severity, critical, warning, info, table space, what type of category. So if you make all this, it will make your life easy. Think about it. If it's clumsy and raw, you like it, means how LLM will interrupt it. It can take severity, info to category, table space. What will happen? So everything now become a structural event. So this is the, oh wow, this is my full table, this is full structure. This should be good. This is what allow deterministic. This is what allow LLM to decide deterministic routing and reasoning. It will tell whether it should tablespace will go to DB agent, or whether it should go to storage agent or to SQL tuning agent. But the target DB after that, LLM, it makes LLM reasoning deterministic, and that's what we want. So all of you were waiting for the set. Intelligent routing, context-aware decision, route to specialized agent. Again, I already covered it initially. I gave you a hint. Our routing is rule-based. What that means? Category-based routing. Whether it's a Postgres DB, Oracle DB, what kind of severity of alerts are there, environment-aware policy, whether it's production, non-production, production don't drop table, non-production you can do whatever you want as your company policy allowed, but again don't drop table there even. What's the priority queue management? What you want to do if you have like thousands of DB alerts, you want to prioritize production alerts. What's then context aware decision? Again same duplicacy, maintenance window awareness. You don't want, if there is a maintenance window, LLM should know kind of blackout this is maintenance window. How you will do that? Think about this. That's what the intelligent routing comes. You need to have context aware decision. If a DB is down, LLM should not reconnect it again. It should read the logs, whether it's shut down by DBA or it should access to MCP server Jira. There is a routing there. You should give LLM more context. And a specialized mapping, which I already explain. You decide it as you see in this normalized weight event. That's why clear data, normalization, structural event is important. Anyway, now what is this rule-based routing? How do I do it? This is the rules. If category is table space, go to this. Category is this, go to this. LLM can decide it. If it's a slow query, go this. Simple Python. LLM is not taking decision for you. If it's a slow query alert, if it's a table space full, if it's a messy, you tell LLM where to go. Again, it's up to you guys. You can have LLM to take this LLM routing decision, but you should have a rules here because I am working on production critical environment where I have maintained and work on more than 800 terabyte database. So yeah. Anyways, so that's why you need these routing tables. Up to you. I prefer this way routing rules instead of going via LLM routing. Supervisor pattern, we know it. Storage agent, SQL tuning, the whole your control plane. Remember, control plane. Your supervisor. You use Kubernetes, it has control plane. What it works to route your request to the port which it needs to serve the API. Same thing, same concept. Remember, LLM needs better architecture decision. Now you're saying, wow, I know it. Yes, you know it. You can do it. It's not rocket science. So why supervisor? Separation of concern. No LLM in routing. Deterministic, fast, predictable, scalability. Add new specialized agent. I can add any more agent, Postgres, anything here. And I need to make control plane aware it. Important concept, important design. You can show to your boss. We want this kind of agents. No matter what architecture you need, this is the standard in industry now. So end-to-end flow, we know that alert trigger, raw input from routing system. Already you have seen it from my GitHub demo. Raptor process it, normalize the event, intelligent routing, specialized agent. Simple. Now you see you have the whole thing. Once you have the raw input, parse it, normalize it, routing, Now you are AI expert, right? But you need to practice it. Create something for your domain and remember structural input is equal to predictable system. Structural input is what? Your JSON schema, which define further your what route specialization router, where to go, which agent to follow. Before we close, this is the foundation of any production safe agent. Don't forget it. And next, don't forget my new video, specialized agent and investigation tool. How I build agent investigate incident with 12 Oracle specific read-only tools. If you are to Oracle, DBA, don't miss it. If you are to agents, AI agents creating enterprise AI